Yes, we are live now, folks. Hey, folks, this is me, Vishwas, and I'm the host of this Kubernetes 101 series from Devtron. A lot of times I've realized one thing, there's a bridge that has to be connected between the basics of Kubernetes to the advanced of Kubernetes that you're really looking back at. And somewhere down the line, you miss out on many things. I think we have Vishal, who is going to give you a lot of insights on Kubernetes, not just Kubernetes, your journey in static Kubernetes. So I think Kubernetes 101 series is going to be a set of professionals we are going to bring, and they're going to give you a lot and lot of insights about Kubernetes, getting started with Kubernetes, certifications Kubernetes, and many more. And I think Vishal is going to be talking about a lot on Kubernetes today, getting started from a beginner's perspective. So enjoy the show, and also don't worry about it. Just ask your questions on the chat. So the chat is open for you folks. And Vishal, the stage is yours.
Thank you, Vishwas. Yeah, so as you mentioned that we will be having a lot of discussion around Kubernetes, but frankly speaking, this is just 101. So we will be having upcoming series as Vishwas promised me. Correct, Vishwas? Because
Yes, I'm going to
yeah,
have so many sessions.
entire Kubernetes 101 is not possible to cover within 1 hour of session. So we will be having the multiple sessions. So that's what is it is called as Kubernetes 101 part 1. So, like, I'll be discussing today about what is Kubernetes, how it evolved, and what is the container orchestrator, what is the architecture of Kubernetes, how behind the scene Kubernetes is working, and like when we take the high level view of Kubernetes, how it works, and what are the basic components. Again, like what are the pros and cons of Kubernetes. This kind of journey we will be talking about today.
Sure. I think you are sharing your screen now, right now.
Yeah.
You
So
can
we
start
can
your
start.
share screen now. Yeah, sure. All right.
Yes.
Hi, good morning. Not able to hear audio. I think you have to go back and look at your audio settings on your system. I think so. That's something. I think you can start with it. I'll start the share screen right now. Sure.
You can see my screen, right?
Yes, I can see your screen. It's a completely shared one. Yeah.
Yep. So Vishwas, let me know when we can start.
Sure, you can start right away. I think people have already started coming up. So yeah.
Okay. Hey, good morning, folks. So today we'll be talking about Kubernetes, and in the next 1 hour, I'll be making sure that you will be understanding journey of container orchestrator, journey of Kubernetes, and what is Kubernetes mean and how it works, what is the architecture. All these basic details of the Kubernetes will be covered in next 1 hour. So I hope that it will be interesting session for you, and I'll be starting. So myself, Vishal, I'm working as a senior DevOps, and I'm having around 7 years of experience as a DevOps engineer. And currently, I'm working with Kubernetes stuff only, and working as a Kubernetes architect mostly. So I'm having around 7 years of experience in Kubernetes. I started working back on Kubernetes when it was just graduated in 2016. Since then, I'm working on Kubernetes. So I have seen the transformation of the Kubernetes, like a journey of the Kubernetes and the organization who earlier like in oppose of Kubernetes and later started adopting the Kubernetes, how they started adopting the challenges they face. So I have seen that phase actually, and then now I can see that Kubernetes is just started. It is not means like still there are multiple organization or multiple companies are looking to adopt Kubernetes yet. Still, like multiple companies are running their workload on the monolith. So now Kubernetes is coming in the market and it is very much popular tool. If you see the survey of CNCF and the Gartner survey as well, then you can see that Kubernetes is in the top three technologies which people are looking for learning. So we will discuss about this popular tool Kubernetes in this session. So let's start. Okay, so this will be the agenda of today's session. So what we'll be covering, like what is the container orchestrator, what is the Kubernetes, what are the features of Kubernetes, and Kubernetes and its evolution, Kubernetes architecture, then Kubernetes component flow, how Kubernetes work, and how the components of Kubernetes works behind the scene. Then like different methods of installing Kubernetes cluster. Then we'll talk about the core concept or core building blocks of the Kubernetes, and we will also discuss the pros and cons of Kubernetes. So let's go ahead. So I'm expecting that you people are aware of containers and what are the containers. So usually when we are talking about container or the Docker container which is installed, or Docker software which is installed on our Mac, what we can, or our machines, what we can do, we are running containers with a single instance. That is really good when we are doing development or we are doing testing of the application. But when we are doing deployment of the production, this same scenario of single host, and single host is running Kubernetes this Docker containers or any containers is not possible. When we are going for the production, then we don't have this liberty. So we need to make sure that our applications which are running on the production should be highly scalable, highly fault tolerant, and they should use the resources optimally. They can discover each other when they are deployed on the production. They can discover each other by their name or by their DNS mappings. Then those applications should have the secure access from outside world, and we need to ensure some methodology with which we can roll back or roll out the application's latest version, or we can just roll back to the previous version. So all these things need to be make sure when we are deploying application as a container on production. And these all things are not possible when we are talking about the single host, and no one is running single host in production mostly. So here the picture of container orchestration comes. So container orchestrator are the tools which group the host together and form the cluster, and they will provide the platform on the top of which we can deploy our application in the form of containers. And we can achieve all these possible scenarios, like we can scale we can scale easily, and we can do that on demand. We can do auto scaling. We can make sure that our applications are being deployed on this container orchestrator are fault tolerant. We can make sure that our applications are using optimal resources. We can make sure that our application which are deployed on this cluster are resolvable or discoverable to each other, and we can just discover them by using their names. And we can make sure that application deployed on this container orchestrator can be accessed securely from outside world by exposing them using some load balancer or using some kind of services or any methodologies there. And with the container orchestrator, we can also make sure that we are doing something called update or rollback or rollout things. So we can easily update the latest version, or we can update the desired version of applications on the go. So that will make sure that all these features are being handled by container orchestrator, and that's why we need container orchestration, because we can't do all those things in the single host. So container orchestrator is the tool which can create the cluster of the host, and we can which can provide the platform to users or to the companies or to the application to get deployed on that platform. So there are like few examples of the container orchestrator which are present right now. Those are like Docker Swarm, Kubernetes, Mesos Marathon, and Nomad. So these are the container orchestration which can provide you the grouping of the host and creation of the cluster, on top of which we can deploy our applications. So now let's come to the Kubernetes, because we are talking about the Kubernetes specifically. So what does it mean by Kubernetes? So if you go to the kubernetes.io and their website, then you can see this definition of the Kubernetes. Kubernetes is an open source system for automating deployment, scaling, and management of the container applications. So if you just go back and if you just check these features, so you can see similar features there in the definition of the Kubernetes. So Kubernetes is nothing but open source tool which was developed by the Google, and that helps to do the automating of deployment, scaling of the applications easily, and the management of the containerized application together. In the this actually Kubernetes world comes from the Greek. So Kubernetes means helmsman. So the person who, or the pilot of the ship, who is responsible for the managing ship. So if we take this analogy, then we can consider this Kubernetes is the manager of for shipping the containers. So here containers are the our application containers. So we can take this analogy with Kubernetes world. Also, people call Kubernetes as a KTS. So the story behind KTS is there are like exactly 8 characters between K and S. So that is called as KTS as a short form. So how does this Kubernetes build? So this entire Kubernetes has been written in the Golang, and it was licensed under the Apache software. This Kubernetes is inspired by Google's Borg system, and this was developed by Google earlier, and it was donated to the CNCF as open source project by Google. So this is about the Kubernetes. So what are the features of the Kubernetes? So like why Kubernetes is so much famous? Like there are like Docker Swarm, there is Nomad, there's like Mesos Marathon. There are like multiple container orchestrated tool in the market. But why Kubernetes is that much famous? So Kubernetes has some features like automatic bin packing. So automatic bin packing in the sense like when we are deploying the applications on the multiple nodes, then Kubernetes will make sure that like those applications are deployed on any particular nodes or nodes in using the bin packing algorithm. So it will make sure that like no resource will be wasted or the minimal wasting of the resources. Kubernetes also provide the self-healing feature. So let's say if you have deployed your applications and by any chance your application just got crashed, Kubernetes will make sure by using its liveness and readiness probe, it will make sure that like application is coming up back. So it is called self-healing. So Kubernetes provide that feature as well. Kubernetes provide the horizontal scaling. So this kind of horizontal scaling, you can we can take the example of let's say now we can take the example of ecart, any ecart service, and we are running some festival seasons, and suddenly I'm getting huge number of requests. So at that time of point, we can say that like, if I'm getting this on this incoming request metrics, we can scale the pods automatically using horizontal scaling. So that is used using the HPA, horizontal automatic scaling. So there is something called service discovery and load balancer. So Kubernetes is really good at service discovery and load balancing. So when we are deploying applications on top of Kubernetes, so we can say the applications are exposed using services, and those applications are discoverable to each other using the service names. And those applications can be or those services can be exposed outside using different type of services called node port, load balancing. So using that, we can expose our application outside of world, and that is coming under the load balancing part. Kubernetes also provide really good support for rollouts and rollbacks. So what it can do on the top of like let's say now your application is running version X, and now you have as a developer you have to release new tag that is called Y, that is having latest changes. So Kubernetes can provide the rollout features. So what happened in the rollout feature, new applications will come with the Y versions, and those like once that Y version applications are up and running, then X will be taking down. So this is called rollout. And if say now you are having some issue in Y version, you can quickly roll back. So Kubernetes provides support for easy rollout and easy rollbacks. Also, Kubernetes provide the support for secret and configuration management. So if your application is using some sensitive information, like let's say databases, database host, database passwords, and those some secret credential, you can embed those secret data in the form of secret, and you can use them and you can mount them inside the your application. So your application can consume that credentials or the confidential data. And let's say now you are having some configuration. For example, now you are deploying Grafana on the top of Kubernetes, and now you wanted to add some configuration of the dashboards. So you can embed those configuration in the config map, and you can pass that to the particular application. So that configuration management can be work very smoothly when we are talking about the Kubernetes. Kubernetes also provides the support for storage orchestration. So when we are talking about the storage, that means like we are talking about the persistent volume which are being used by the application. So these volumes are nothing but in the simple scenario, those are will be like hard disk used by the applications. So where applications can store their data. So that orchestration also being taken care by the Kubernetes. So we don't have to worry about that. We just have to specify our storage classes there, and we using the dynamic or the static provisioning, we can use that storage as a volume, and we can use those storage as the volume inside the application will start consuming that storage. So Kubernetes also provide the support for batch execution. So batch execution is like we can provide some jobs, we can use cron jobs, we can use some normal jobs which will run to complete, and we can use the cron job to schedule a job at a particular time. So Kubernetes also provides support for this kind of batch executions whenever we require them. And the best feature of the Kubernetes is like Kubernetes is platform independent. So Kubernetes can run on bare metal, it can run on public cloud, it can run on the private cloud, or hybrid or multi-cloud. So Kubernetes support all these setups, so you can implement your cluster on any of this platform. So it is considered as the platform independent tool set. So how Kubernetes come in the action, like how sudden Kubernetes come in the action. So if you read the abstract of the Google's Borg paper, which was published in 2015, the Google's Borg system is the cluster manager that run hundred of thousands jobs and many thousand of application across the number of cluster, which which can be means like cluster of 10,000 machine, on top of which they used to run this multiple kind of workload on top of that. So this Kubernetes has started evolving from this Borg system. That's why Kubernetes was written by Google, which was inspired by the Borg system. And like if we take the some features which have borrowed by Kubernetes from the Borg system, those are like API server, pods, IP per pods, services, and the labels. So all these features are being used by the Borg system and which has been inherited by the Kubernetes. So we can consider this Kubernetes has been evolved from this Google's Borg system. So Google Borg system was there since like long time, and in 2015 Google started developing the Kubernetes, which was inspired by the Google Borgs. So this was the evolution of the Kubernetes. So when we talk about the Kubernetes, so here what we think Kubernetes is the clusters. Kubernetes is the cluster of multiple nodes. But actually Kubernetes is something called control plane and the data plane. This is a collection of the control plane and data planes. So control plane, when we are talking about the control plane, those are the master nodes. And when we are talking about the data plane, those are the worker nodes. So this is the complete architecture of the Kubernetes actually. So the control plane will be sitting here, and those control plane will be having some components, and there will be some worker nodes, and after worker nodes there will be something load balancer which will be pointing to the application running on these worker nodes. And there will be like end user which will be trying to access those application using load balancer, and the application will be being served from the node. This will be the complete architecture of Kubernetes, but we will go in the deep how these components work each in details. So let's say when we are talking about the Kubernetes architecture, then like we will take first is the master nodes. So in the master nodes or the control planes, so those are also called as control planes and master nodes. So there will be like odd number of masters, or you can say odd number of etcd. If etcd is the part of the master nodes, then we have, as per the, there is one algorithm. So as per that algorithm, we have to keep that odd number of master node if you are creating the HA kind of cluster, that is high available cluster. So let's say now these are the component of the master nodes. So that is a etcd, control manager, scheduler, kube API server. So we will talk about one every component one by one. So first thing is that kube API server. So API server is nothing but the, you can say, brain or the heart of this control plane. All communication is happening via the API servers. So let's say now I'm the end user and I'm typing something like kubectl and something. So all this authentication, authorization, syntax verification, everything is being carried out at the kube API servers. So what, like whether I'm allowed to use access or not. If I'm let's say the I'm end user and I'm just typing something called kubectl gate pods or kubectl gate nodes, then like I am the end user, I will be typing my command, it will go there, and kube API server will validate, like it will try to authenticate me whether this particular user is having access to talk with me, whether he has the correct keys, whether he has given like correct access, that is covered in the RBAC, role based access control. So in that section we can give the privileges, or we can give the access to individual user or the group of the users, so that API server will validate whether this particular user is having access for this node, getting nodes. Yes. So this API server is acting as the communication agent between all the components. So let's say now my controller want to communicate with any of the node, that will communicate using the API server. So all components in the Kubernetes system talk to each other using API servers. So there is another component called scheduler. So scheduler, the job of the scheduler is the, like let's say now we want to deploy a pods on the nodes, or we want to deploy a deployment which is having two replicas of the pod. So what will happen, this scheduler will make sure that like I will deploying this on the nodes. So what will happen, so this particular scheduler will get the list of the nodes and the list of the nodes which are having enough resources from the etcd that will be passed by etcd to kube API server and API server to scheduler, and it will decide as per the scheduling policy. If we haven't given any labels, any annotation or node selector, then it can deploy the applications or those pods on the random nodes. But if we have given the selectors, stain, toleration, those kind of thing, then it will calculate which are the best fit nodes on, and on those particular node it will deploy those pods. So there is another important component is the controller manager. So in the Kubernetes, there are like different kind of controllers, like deployment controller, pod controller, node controller. So the job of the controller is to maintain the life cycle of that objects, maintain the lifecycle of object. So let's say now we are talking about the deployment controller or the replica set controller. So what is the job of that controller? So controller will make sure that like current state is equal to desired state of that particular objects, and all those applications is required. So let's say now I have decided I want 3 pods of the applications. So what my deployment controller will ensure that like I have to make sure that like 3 pods are being deployed in this Kubernetes cluster. Let's say one of the node which was running my pod goes down. So now there are like only 2 pods running in my cluster. So this controller will make sure that like, oh, now current pods are equal to 2 and desired is equal to 3. So there is mismatch. So it will again ask scheduler. So buddy, there is mismatch in the condition. Go ahead and deploy one more pod. So controller is nothing but it will make sure that taking care of life cycle of objects. And there is another important component that is called etcd. So etcd is nothing but it can be considered as the brain of the Kubernetes. So it will store all the configuration, all the details of the cluster, all the state of the clusters. So many people also call etcd as the database of the Kubernetes. So it will store the state of the Kubernetes cluster inside the etcd. It will store the values in the key value format. So let's say now for example, now I have given the a request to create new deployment with the 3 replicas. So how the flow will work? So my kubectl will go here. Kube API server will validate and authenticate my request. Then what will happen? Then it will pass this to the scheduler. Then what will happen? Scheduler will check the nodes, which will get the data from the etcd. It will store the data of nodes, available resources on the each node. It will find out the nodes, and it will deploy the applications. Then controller will be informed that now I have deployed this, and this current state is equal to desired state, and the data will be updated in the etcd once application pods are deployed. So these all things works in the control plane. But now when we are talking about the node plane or the worker node planes or data planes, so how the things will work? So let's say now I have given kubectl apply or kubectl create deployment. Now this scheduler has asked which are nodes available, and it has selected the nodes. So now let's say now they have selected node 1 and node 2. Then what will happen? Scheduler will pass the request from kube API server to this nodes. So on every nodes there is one essential component is running as kubelet. So you can consider this kubelet is running as a daemon on every nodes, and using this kubelet process, this data of the nodes and the deployment on the nodes will be taken care by this kubelet. So this kubelet is running on every node, even mask node as well. So using this kube API server, scheduler will inform to this kubelet. So buddy, we want to deploy this particular application pod on this node. So what will happen? Kubelet will check which image. So what will happen? The kubelet will check. Let's say now I want to deploy Nginx image. So kubelet will ask container runtime, either that is CRIO or Docker. It will ask that runtime, hey, just pull this Docker image or any image and start deploying the container there. So kubelet will ask container runtime to create the pod there. So this will create the pod here, and it will inform the pod has been deployed. Then kubelet will be having the something called health checks. So it will be keeping the health checks. So there are like two types of health checks mostly used in Kubernetes. That is, one is readiness probe and one is liveness probe. So kubelet will make sure that like pod is up and running using the readiness probe. So once it become one by one, it will update the status in the etcd that pod is up and running now. So same thing will happen in the node 2. So these are the components of the worker nodes: kubelet, runtime, and there will be another component called kubeproxy that will be also the part of every node, but it is mostly considered as the part of the data plane. So what is the job of that kube proxy? So kube proxy is nothing but whenever we are creating new pods or whenever we are creating new services, it will update the IP tables accordingly. Let's say now I have mm, one applications, that is the front end application called WordPress, and I have deployed two pods here, and those applications have been exposed with some services. So that service will be having some IP, and that kube proxy will update the service and it will update the backend. So backend is nothing but the pod's IP. So all these things are carried out by the kube proxy. So this is the basic architecture of the Kubernetes, how Kubernetes work behind the scene. In like we will also discuss these things in the next slide. That will be like workflow, like how this workflow will work when we talk about the Kubernetes. So if we take the high level architecture view, so this is the view. So as a user or a developer, those will be communicating with the API servers using API server. API server will talk with the controller and the scheduler, and API server will also talk to the etcd cluster, and those API server will also talk to the kube proxy, kubelet, and docker. That will be runtime, any runtime. So this, we were talking about this kube proxy. So this kube proxy is nothing but it is responsible for maintaining the IP tables of the services on every nodes. So like you can ask me like what is the use of IP table. So let's say now I have deployed like I'm going in detail, but let's say I have deployed WordPress application on these nodes, and they're like one of the replica is running here and one of the replica of the WordPress is running here. Okay, and I have exposed that to the external world using a load balancer type of service, and I'm the some like there are some end user, those are accessing those service using the load balancer type of service. So what will happen, this load balancer people will hit this load balancer. Okay, and this load balancer will be having the mapping of the nodes, and it will forward the traffic to this particular nodes. So now actually if you see, the traffic will be coming at the physical network of the nodes, but this Kubernetes pods, containers, those are running inside the inside the nodes, and those are running in their own networks. Those will be running with the BR0, their bridge networks. So traffic is coming at this particular physical network of the node, and like how you will make sure that like now from the physical network traffic will go inside the this virtual network of the Kubernetes or virtual network of the pods. So the kube proxy will make sure that those will be updating the IP tables rule on every node. So it will update that like if the traffic is coming at this particular port from external world, forward this to the this particular virtual IP of the service from where this traffic will be forwarded to the pods. So that functionality is being taken care by the kube proxy in short. So this will be the high level architecture view of Kubernetes. So now how this component API work, or you can say API workflow works. So let's say now we talked about the controllers, we talked about scheduler, we talked about nodes. So how this flow will work. Let's say now you're the users, or you wanted to create any deployment. So what you will do, you will use any mechanism called kubectl, or you can use the APIs. So what happens, this API server will get the request, and it so now user want to create the deployment. So what will happen, so it will create the deployment event, and it will ask the deployment controller to the create the deployment create event. So what will happen, deployment controller will create the event, and it will ask it will update the we have created the replica set, and from there the next workflow will go to the replica set controller, because under deployment there will be replica set. And once replica set event created, then what will happen, then it will ask uh, scheduler to create the pods. So these are like events, so it will be sending the communication from the APIs. So flow is working from so now you can see here every application is talking to each other using API only. So now API is asking deployment controller to create the deployment. Now what will happen, deployment will talk back to the replica set controller using the API. So it will ask create replica set, from where the request is going back to the replica set controller. So replica set controller is asking now create the pod. So what will happen, this replica set controller will set the request to scheduler, but it can't directly talk with the scheduler. It will talk with the scheduler using API only. So what will happen, this replica set controller will send the request to the API server, and from API server it will go to the scheduler. So what will happen, this particular scheduler will check the request, and it will ask, okay, now I have to talk with the kubelet. So what will happen? This now scheduler want to talk with the kubelet. Again, the request will go back to the API, and from the API it will go to the kubelet, and it will ask to start the containers. And once this particular application pod of the container is started, it will start updating the status back. So it will, like in the reverse way, it will start. So kubelet will update to the replica set, the replica set will update to the deployment, and deployment will update to the etcd. So this is the complete workflow works in Kubernetes. That's why we are talking about Kubernetes API is the heart. It is very much important part of the Kubernetes control plane. If Kubernetes API goes down, your entire workload which is running there, it can continue to run. But extended functionalities like HPA, extended functionality like controller checking for the active desired state is equal to current state, or current state is equal to desired. Those kind of operations won't be possible. So it will be considered as orphan workload. So this API is the very crucial part of the Kubernetes control plane. So this is the different kind of installation methods available in the day-to-day life, like which we can
Just one
implement this.
question,
Okay.
Vishal. I think one question. I think before going hand, here Naveen Kumar has asked something like use of CNI and core DNS. So if you can just brief out a little bit, and then you can start continuing with the talk.
Okay. So so CNI. So let's say now here when we are talking about worker nodes. So what will happen in this kubelet? So CNI is nothing but the container network interface. So whenever one pod is coming up, so the job of the CNI is to assign IP per pod. So every pod is having unique IP, and every pod is having their own network namespace. So CNI will make sure of making its own namespace and assigning that IP to that particular pod. So this is the job of the CNI. So that will be the another component of the Kubernetes, which I was planning to cover in the next session, because this container networking itself take at least 1 hour, or at least it will take more time. That's what I was planning to cover this in the next session before going to the actual hands-on. But when we are talking about the CNI is the component of the worker node or any node which is responsible for assigning the IPs, taking care of the IPs, and creating the network namespace per pod. And using that, pod will get their own IP address. So that is the job of the CNI. So Kubernetes by default support for the CNI, that is the native CNI. But mostly people will go with the something called Calico, ViewNet, and Flannel as per their requirements. Mostly people will go with the Calico because Calico supports for the multiple functionalities like network policy in those people. So people will opt those when we are configuring the clusters. And what was the next, Vishwas? Vishwas? DNS.
That's it. There was no other questions that they wanted to ask, and that's the only one question that they had. So you can
The next,
continue.
the next was DNS, correct?
Yeah, the core DNS. Yeah,
Okay, so core DNS is the nothing but it is acting as a DNS servers. So when we talked about here, application can discover each other. So how the application can discover each other? So there is one component of the master node. Those will be like DNS pods. So those will be acting as a DNS server. So when we are creating any service or when we are creating any pod, it will update the DNS record and it will create the DNS record in that DNS pods. So when we are talking, let's say I have deployed one application that is WordPress, and I have deployed another application that is backend database. So my WordPress application is exposed with a service called WordPress, and my backend application is exposed with a service called backend. So now my WordPress application can directly communicate with the database applications which is deployed on Kubernetes by just talking the service name or the host name, or let's say host or that service dot namespace name. That will be acting as FQDN because of this core DNS. So this core DNS is the maintaining DNS record for the services and for the pods. That's why it is important, and this again will be the part of Kubernetes networking. So this core DNS is used for resolving the application pods and application services to each other.
Yeah, I think perfect. Thank you so much for answering that. I think if there are any questions coming up, I think you can just ask it. So don't
Yeah,
worry, even if I think folks don't worry about it. There is always a myth that you have to be an expert to ask some questions on Kubernetes. Don't worry if you are from a mainframes person, and if you want to evolve all of the sudden into Kubernetes, that's going to be challenging. I think ask with reference to mainframes, ask with reference to serverless. There is a lot coming up in the market. So yeah, let's move on, Vishal.
yeah. Sure. Okay, so they're like available installation methods or available Kubernetes setup methods are Kubernetes hardware. So the folks who are preparing for the CKA exam, those will be very aware of this Kubernetes hardware. So Kubernetes hardware is the this was used when there was no particular tool available in the market back in 2016. There was only like kubedium was available, cops was available. So that time when people want to create the Kubernetes cluster, they used to do this using the from scratch method. So they used to set up every services, like let's say kubeproxy, kubelet, and the docker. They used to set up every services as Linux services on every node, and we have to configure the sections there. We have to configure we have to configure the configuration for every component manually. So that is this Kubernetes hardware. For this purpose, you can search on the internet KCI towers, Kubernetes hardware. There you'll get the good repo, good GitHub repo. He is demonstrating there every single step there. So it will be having, let's say, if I just show you here, this is repo actually. In this hardware, he has explained everything, like how we have to go, like how what are the components, like for everything we have to set up manually, like we have to set up every single component, we have to configure every single component. So he has given these details there. So that was the method which was earlier used, and in this method we have to set up each and every component of the Kubernetes manually from the scratch. We have to write down those configure, and this is the hardest method actually. That's why it was part of the CK exam. So people who wanted to be like certified Kubernetes admin, those people should know like how we can set up the Kubernetes cluster manually or from scratch without using any installer. So that is the Kubernetes hardware. So there is another type of method that is called installer based unmanaged Kubernetes. So now there are like two types of Kubernetes. One is managed and another is unmanaged. So managed Kubernetes is that Kubernetes cluster is being managed by third party. When we are talking about unmanaged, then entire cluster is being managed by the Kubernetes admin. There won't be any person to manage your cluster. So that is the big difference between managed and unmanaged Kubernetes. So installer based unmanaged services. So everyone is using, like when we start playing with the Kubernetes, people will start creating the cluster with kubedium. So this kubedium is nothing but the installer based Kubernetes installation. In this Kubernetes kubedium, what you will do, you will just set up the you will install the binaries of kubedium, uh, kubectl, cni, docker, or any container runtime on every node of every single node. And then on the master node you will initialize using kubedium command, and that will pop up it some token. You have to go to the next node and you have to use that token so that worker node can join to the master. So that kubedium was used uh, initially. And now earlier that kubedium was not the production ready or GA. Now I think kubedium support for the HA cluster as well, so we can use that in production as well. And there was old method, I think many people might have heard about it, cube spray. So cube spray is nothing but that is the combination of kube adm and the ansible. So when we have the multiple or we have a list of the host together there, and we want to go with some production ready cluster, we can use the cube spray. So for this cube spray also, you have to manage your cluster using this binary. You can just spring up the cluster and you can use. So cube spray was being supported by multiple cloud vendors like aws, azure, and gcp, and it was also having support for openstack as well. The similar methodology was COPS. So COPS and KubeSpray was similar actually at that time they were competitor. So COPS also using the same thing. So COPS also support Kubernetes installation, and it will also talk with the multiple cloud vendor like OpenStack, then GCP, DigitalOcean, then I think AWS and Azure as well. So these are the installer-based unmanaged Kubernetes, installer-based unmanaged Kubernetes types. So there are like multiple folks who are having Kubernetes single node Kubernetes running on their own machines. That is either Minikube or they are having Docker for desktop, and Docker for desktop is having feature for Kubernetes. So you can enable that, and you can just start using Kubernetes for your own development. You are writing down small applications there, then you can use this. If you don't want to go for the production for testing or deploying, developing your application, then you can use this single node clusters there. And when we are talking about nowadays production grade cluster, or the cluster which are widely used, and even in the market everyone is looking for this kind of job requirements. So what people are looking for, managed Kubernetes cluster. So there are example like EKS, AKS and GCP. So here you can say GKE actually, but I have written GCP. So what are the managed Kubernetes? So in the managed Kubernetes, every component of your cluster is being managed by the cloud provider or the cloud vendor. So when we are talking about the EKS, we just have to give the we can use the command, or we can just bring up the cluster there. We just have to provide our groups, security groups, and those VPC there, and they will bring up the cluster with the size of node we are providing there. We can manage the fleet, or we can ask them to manage the fleet. So all this Kubernetes cluster is being managed by the cloud provider. We don't have to worry about that, like whether my node is going down, whether my master is going down, or whether my components on the master is going down. You don't have to admin that cluster. Cloud provider will take care of everything there. Even though you are, let's say you are having some issue in the manage, and you won't get easily like access for the master components. When we are talking about the managed Kubernetes, they will manage everything for you, and they will charge for that management. So those are the popular Kubernetes clusters which are being used in production. So for me, my entire workload is running on the EKS mostly. For my earlier company, the workload was running on the GCP, and like multiple folks might be having running workload on the Azure, and that will be in the form of Azure Kubernetes service. That is the kind of managed Kubernetes provided by the Azure. So these are the Kubernetes installation methods there. Okay, so when we are talking about the core component or core building blocks of the Kubernetes, so people will talk about the pods, people will talk about the controller, people will talk about the services, people will talk about the multiple things there. So what are the core components? What do they mean actually? So we will talk here. So everyone might have heard about pod. So pod is nothing but when we are deploying workload on the top of Kubernetes, it will be in the form of pod, not as the container. So pod is nothing but it is the combination of one or more containers. So you might ask like why? Because when we are talking about the Docker, or when we are talking about the container, we are deploying application as the container. Why it is coming as the pod? So why this feature, like pod may be having one or multiple container inside that. So why the pod function is coming? This particular pod is the single unit of deployment on top of Kubernetes. So why pod is having multiple container, combination of multiple container? So let's say now take the example of you are running one database pod, and before running the database pod, we want to pull up some schema from remote repository, and you have to pass that database schema to your database container. So how you will achieve this with the Docker? No, that is very difficult. Or either you have to put that schema in the config map, or it's inside the pod only, so that application can use that schema. So what will happen? Pod will enhance the functionality by providing additional containers like init container, sidecar container, ambassador container. That kind of additional or helper containers are adding along with your main application container. That's why pod becomes so much popular. So pod is nothing but it is the combination of one or multiple pod or multiple containers. So that is the example. Let's say we talked about that particular schema. So what will happen? I will spin up one init container. So init container is similar to the init process. That will run first. That will pull up the schema, and that will pass that schema to the next container, because the container running inside the same pod are sharing the same network space, and same I think same system player, what do you call, disk space. So they can share the volumes. So let's say now I'm having 2 or 3 containers running in the single pod. Those will be sharing, those can share the volumes with each other. That is the beauty of the pod. So labels and selector. So labels and selectors are used very widely in Kubernetes. So what is the use? So in the Kubernetes, we are having different kind of workloads or different types of workloads deployed there. So how you can use that labels and selector? So let's say by the label we are adding, we are putting additional tags, and using this label we can use the selectors to group those objects with particular labels. So let's say now I'm running like let's say I don't have any you can say distribution or for pre-prod and the staging. So what I can do, I can add the labels for my application who are in development stage or staging stage, and I can add another label for the application who are in the pre-prod stage. So using that label I can select the pods which are running with the label stage, and I can select the pod which are running with the label pre-prod. So using that labels we can group the application or kind of objects together. So that is the use of labels and selector. So this labels and selector also used in the service. So when we are talking about the service, Kubernetes service, like cluster IP, node port, and load balancer. So these uh, pods with running with the particular labels are being selected for serving the traffic. So when we see configuration of any services, there you can see selector. So this selector will do, it will select the pods which are running with specific labels. So that is the use of labels and selector. So controllers. So there are like different kinds of controller which provide the different kind of workloads. So when we are talking about deployments, we have already talked. So deployments will make sure that like it can have that multiple replicas or multiple pods running with a single deployment, because when we create the single pod we can't scale that. If we just deploying the single pod we can't scale that. So if you want to achieve scaling, roll out those kind of feature, then we should deploy the application as a part of deployments. So what will happen, this deployment will create the replica set behind the scene, and that replica set will maintain the replicas of the pod. So that's why we need the deployment. So similarly replica set, either you can deployment can create the replica set, or we can create direct replica set object kind of object. So what will happen then, again replica set will maintain the replica of the similar pods. So earlier this replication control were used, later it was replaced by the replica set. So now I think replication controller is not being used actively, because Kubernetes mostly use the deployments. No one create, I think as per my understanding, no one directly create the replica set object. People will always create the deployment. Behind the scene deployment will create the replica set. So let's say now I'm running a deployment A, and that deployment A will create the replica set A dash hyphen something hyphen XYZ. So now that deployment A is running with Nginx stable image. Now I did the rollout, or I updated the image of that particular deployment A. So now I said I want to use the Nginx hyphen alpine image. So what will happen? This deployment will create the new replica set, and this replica, earlier running replica set will be scaled down to the 0, and new replica set, that is A hyphen now ABC, will be having the latest image, that is Nginx hyphen alpine. So now the earlier replica set will be there, but it will be scaled down to 0. Now new replica set is running new image, and the single point, single time, or at the single point of time, I want to roll back. Then what will happen? My deployment will again start pointing to the previous replica set that was running Nginx hyphen stable, and this newly created replica set will be again scaled down to 0. So that's what the deployment and replica sets are doing. So the third important point is the daemon set. So let's say now we are running some agent kind of applications. For example, we are saying we are using node exporter, or we are running some logging agent, and we want those pods are running on every single node available in the cluster. So you can't do that easily with the deployment. Because you have to make sure that like how many nodes I'm having. I have to add the some what we call affinity and affinity kind of thing. Instead of that, we can use daemon set. So this daemon set will make sure that exact one replica of the pod is being run on the every node. Like in the daemon set, you can't have the two replicas of the same pods are running on single node. No, that won't be happen. That will make sure that only single replica of the pod will be running on the every node. And this daemon set is applicable when we are talking about the logging on monitoring agents, and we want some applications to be run as daemon set on each and every node. So this daemon set is being used at that time. So when we are talking about the service, so service is nothing but it is the objects created inside the Kubernetes to load balance the service to the pods. So in the if we just click here for the service section, so what will happen? This service, so service is this kind of configuration it will be having. So it will have the selector. So it will select the pods running with this particular label. And here we will define the port of the service and the target port of the pods. So this is the service definition, and this is the pod definition. So this particular service will target to the pods which are running with this particular labels. So that's why selectors are being used here for selecting multiple pods if we are having multiple pods running there. But usually in the scenario, single service should target to the single group of pods. So let's say now I have deployed the WordPress pods and like WordPress deployment, and that is having 3 pods, and I have created the WordPress service. So this WordPress service should point to the pods running with the WordPress deployment. It should not point to the pods running with backend deployment. So for that purpose, we have to make sure that this label should be unique, and we are giving proper labels, because sometimes we might face this kind of issue. We have deployed applications, we have created service, but traffic is not being routed correctly, or we are getting some 5x6 kind of errors. That time we have to debug that whether my service is having correct selector there, if my service is having correct endpoints. That is the thing. So another kind of workload or another kind of object block is the stateful set. So mostly when we are running the applications which are stateless application, we usually use the deployments. So when we want to run some stateful application like database application, some Redis, or some let's say Elasticsearch or the Prometheus kind of application, then we prefer the stateful set kind of workloads. So what is the stateful set and why it is so much important? So when we are talking about the stateful set, so stateful set will allow you to create the pods with the particular what we call chronology. So it will make sure that like pods are coming with the names. Like, let's say now I'm creating the stateful set for any Redis application, then pods will come like Redis-1, Redis-2, Redis-3, only or Redis-0, Redis-1, or Redis-2. So that 0 will be the first created pod. After that, Redis 1 will be created, and after that, Redis 2 pod will be created. And if I just delete Redis 3 pod, the new pod will come, and that will be having the exact same name, Redis 3. So that's why whenever we are having the stateful kind of workload or stateful kind of applications, then we use the stateful sets there. So this will be the definition or the YAML definition for this particular objects. So this will make sure that pods are coming with the particular ordinal index. So those will be starting from the 0 and go up to the n-1s. So like if I have preferred, if I have given the 3 replicas, there will be like, what is the name here? So web. So it will create the pods with the name web 1, web 0, web 1, web 2, that kind of things. So that's why this stateful set is really important there. So the next part is config maps. So when I think we have already talked about this, and again I will explore. Let's say now I'm running Grafana as a stateful set, and I'm having some dashboards there. So I can use the like Grafana link, and I can get the dashboard ID from the grafana.com, and I will just import that dashboard. But that is like you can say those are like non-persistent database. If I restart the pod, those data will flow away. So if I want something like configuration which should be injected while creating the pod, then I can add those dashboards as a config map inside that particular config map configuration. So this config map might be having the parameters like this. So in this config map, we can add the data like this. So if I wanted to add some properties, if I wanted to add some environment variable, I can add those in the config map. And those config map can be mounted by or used by the pods either as the environment variable or either as the volume. So we can mount this config map as an environment variable, or we can mount this as volumes. So there will be multiple kinds of config map which will be having different kind of data. So let me show you. So yeah, so this is like this particular config map is having this key as a data, and this keys have these are the component of my these keys. So and these keys will be mounted as the volume. So that is the use of config map. And when we are talking about the secret, there is no much difference between config map and secret. Both can be used with the same purpose, but the secret are coming in the picture when we have the confidential data. So confidential of data means like when we are having passwords, when we are having some tokens, then we should usually use the secrets. So similarly, we can also give the data here while creating the secrets. So we can create using the keys, or we can use this here. You can say uh, we can use the keys, TLS keys, then passwords, those kind of things. So here you can see the we can mount those secret as a either volume, or we can use them as a environment variable. So whenever we want to create the secret, we can use the different methodology. Let me give you one example there. Yeah, so this is the example. So this is this like secret. This is like simple kind of secret, and in the secret file, this is the base64 data of that particular secret value, and that will be mounted as the volume here. So this is the part of secret. So these are the like object. So when we start doing operations, or when we start exploring the Kubernetes, we should know all these building blocks, like how we can deploy application. So while deploying the application, we can use these building blocks, or pods, labels, controllers, services. So we should understand these things when we are deploying the application on top of Kubernetes. So there is something called persistent volume. So persistent volume is very much important nowadays, because this is nothing but the attaching the storage to the container. So let's say now I have deployed my applications, WordPress application on top of Kubernetes as a deployment. But now I'm creating the new dashboards, and I'm entering some data. So that data should be stored somewhere, or else what will happen, that pod, if that pod got restarted, all this created data on everything will be flushed away. So for that purpose, what we need something called persistent volume. So we can attach the storage to the container using this persistent volume. So we when we use the persistent volume, we can use either like a cloud provided volume, or so those will be like either your NFS kind of volume, or you can use your own created volume using Rook or Ceph or cluster.fs. You can create your own kind of volumes, you can create your own storage classes, and we can attach some persistent storage for your containers. So what will happen if my container restarted, or it goes down and new container comes up, that new containers can attach to that storage, and it can start working from the exited state, and it will be having the data. So data will be stored, there will be no loss in the data. That is the reason of using persistent volume there. So we can attach this storage to the container. So guys, don't worry, in this section I'm just making sure what are the concepts there. In the next session we will be going with the practical things, so you will get more idea about those things actually. So right now we're just covering the concepts actually. We are not doing any practical sessions right now, but in the I think 101 part 2 we will be definitely going with the creation of the cluster and deploying these applications, objects, and everything there. So when what are the important life cycle of the application? So first is like updating the pods, rolling updates, and rolling backs. So updating the pods in the sense like we can update the replicas, we can just scale up, scale down. We do the rolling updates. So in the rolling updates, what we'll do, we will roll out the new images of the that particular pod, and we will roll back. In the rollback, we will be rolling back to the previous images. So these are the important lifecycle applications, lifecycle of the applications we are performing on the day-to-day basis. So when we are talking about the Kubernetes, like there are like multiple benefits or multiple pros are there of the Kubernetes, and we are talking about the Kubernetes. So first thing is that improve the productivity owing to the huge ecosystem. So what's happening with the Kubernetes? So Kubernetes is creating the platform for deploying your application. So you don't have to worry about the ecosystem. You don't have to worry about the what we call what is running behind. You just simply create your application Docker images, and you just use the CI/CD. So using CI/CD, you can easily just deploy those applications. You're you are fastening the speed of your CI/CD processes. You don't have to worry about your ecosystem. It will improve productivity of your applications. So fast development, fast deployment, and fast testing. So that using that, we are using the productivity. Another thing is like sorry, I think here I think I repeated the ecosystem. So another thing is like CNCF community support. So when we are talking about Kubernetes, so Kubernetes is very much popular product or very much popular project of the CNCF, and there is like wide community support for that. Like, so if you are having some like a different kind of issue, or you some very unusual issue, you will get community instant community support. If you just paste there on their Slack group, you will definitely get supported there. And see, it is also being released time to time in the time to time manner. So it is getting like security patches, security updates, and with every update it is getting rigid and solid. Another thing is like future proof. So people have already started working with the Kubernetes. So with the Kubernetes, they're looking that there will be future. So people started developing their applications, and they're going in the future. They're designing their applications by keeping Kubernetes in their mind. So, and they're also having the huge tech stack which is supporting to the Kubernetes. So when we are talking about Kubernetes, we are getting something called Istio or service mesh. So it will additionally add the on control over the network or control over the service to service communication, and it will additionally add some extra features like you can say a fault toleration, or the canary based traffic routing and everything. So those future based concepts are being served when we are talking about Kubernetes. And Kubernetes also allowed us to use variety of workload, and that also gives a different kind of deployment option. So as we talk, Kubernetes allow us to do stateless deployments using deployment objects. Kubernetes also allowing us to deploy applications which are stateful, like databases using stateful set. Kubernetes also allow us to deploy application as a batch jobs using simple jobs. Kubernetes also allow us to do deploy the cron job, which are timely manner using cron jobs. Kubernetes also allow us to deploy the daemons on every node using daemon set. And Kubernetes also support various deployment options. So Kubernetes supports something called simple like a rolling out option. So in the rolling out, what will happen? Let's say now 3 pods of Nginx stable is running, and now I'm deploying new change, that is Nginx Alpine. So what will happen in the rolling update? It will bring up one pod from this like there will be a scenario, you will give max search and update things. So it will bring up one pod, and it will bring up one pod down here. So it was like a rolling update. So it won't take this particular thing down, and it will like simultaneously bring up the new pods and take down the old pods. So that kind of deployment option you get. Another, you will get recreate. So whenever you want to use the recreate operation option, that is destruction or destructive option, like it will just completely delete the earlier deployment and it will bring up the new deployment. It will also support something called canary. So in the canary, like uh, let's say now canary, everyone is aware of canary, but canary, like one deployment is running, new deployment will come in the ecosystem, and a few requests, or 10% or 20% of requests will be served to by the new applications or new version of the application, and 80% will be stored to the older. So using that, we can test the applications using this canary, and once we are 100% confirm about like new applications is trying or it is working as expected, then we can just gradually shift the entire traffic to the newly application. So this methodology is called canary. So that kind of canary deployment is also being served by the Kubernetes. And the next part is called A and B. So A and B deployments are we can say you can have both A and B running inside the cluster at the same time. You just switch the traffic from A to B and B to E. So this kind of different type of deployment option is being served by the Kubernetes. Kubernetes also enhance security. So when we are talking about security, then like Kubernetes make sure network policy, so you can restrict the access to your applications, like who can access, who can not access, which services can talk to my service, which services should not talk to my service. So these kind of enhanced security options, or let's say you can use the pod security policies there to making sure your application should not use root privileges. Your application should not use more what we call capabilities than required. those kind of security measurement can be taken care in the Kubernetes. So Kubernetes help us in enhanced security manner. The next important part is Kubernetes is having compatibility with major cloud provider. So now let's say you have workload running there, and you can run those workload on multiple uh, cloud, because Kubernetes is being supported by every major cloud providers. So there is no point of vendor locking. So when we are talking about Kubernetes, you can deploy application as a deployment. So either it is on Azure, either it is on AWS. Unless, like say, there is vendor specific locking is there, you can free to deploy your application on any cloud. So it provide the compatibility of no vendor locking. So that is the use very much popular feature of the Kubernetes, and that's why it is very much popular. So when we are talking about the cons, so the like steep learning curve. So when we are talking about the Kubernetes, I think, as per my understanding or as per the experts' understanding, which has published on the CNCF, so you can read multiple blogs about this steep learning curve. So learning Kubernetes is not easy for multiple folks actually, because Kubernetes not itself is coming with the single things. You, if you want to learn Kubernetes, you start with the uh, containers. You should know containers, you should know CNI, you should know CSI, everything you should know. So there is like huge learning efforts are required for learning this particular Kubernetes. And there will be like a dependent ecosystem of the Kubernetes, like service meshes and the monitoring system. Everything should be learned when we wanted to deploy anything on the Kubernetes at the production level. So you should not only understand the Kubernetes, but you should have to learn everything about Kubernetes and ecosystem of the Kubernetes, like different kind of projects. The another very big or very painful challenge is like migrating existing applications to the Kubernetes. So let's say now your application is running on legacy platform, or your application is running with the old tradition, and now you just simply you wanted to convert that, or you just wanted to run that on the top of Kubernetes. That is very much difficult actually. So first thing is that when we are talking about Kubernetes, we visually recommend the microservices. So your application is monolith or the legacy application, then you have to make sure, or you have to spend some your efforts to decoupleize your application in the microservices, and then it should be deployed on Kubernetes. That require huge pain, huge efforts. So that is the actually pain point when we are migrating from the legacy to the Kubernetes, because you have to write down a Docker file, you have to test whether like that when we are decoupling the application components or microservices, those are talking to each other, how those are talking to each other. And that will additionally increase the complexity as well. When we are just decoupling the single application into multiple microservices, then it will additionally increase the complexity, because we are managing them independently actually. So it also requires the vision from the beginning. So let's say now you want to deploy something on the Kubernetes. I Many people from the CNCF or many experts from the industry, they believe that we should require vision from the beginning. So if we want to deploy anything on the Kubernetes, we should keep that thing in mind while developing our application. So we have to make sure that our application are Kubernetes centric when we are writing them down. So those will be lightweight. There won't be any batch jobs running inside the application. Though instead of that, those should be running as the jobs on top of Kubernetes. So those kind of the planning and those kind of planning execution should be there. And for that, we have to do proper planning and visioning from the beginning only. Third thing is like unnecessary complex for small scale application. So that is also the very much important point. So let's say now you just have the simple application like two three services there, but you just wanted to deploy that on the Kubernetes. So then what will happen? You just have to make sure your cluster is there. You have to maintain, or you have to bring up the cluster. You have to bring up entire ecosystem just to deploy small two three application on Kubernetes. So that is the thing. You have to choose wisely whether it is required or not. If I'm just having like two three or like a very small number of applications, is it really required for me to go on Kubernetes, or I can just continue with my existing ecosystem? So those things are really important when we are talking about, or we are thinking of adopting Kubernetes. So so guys, I think I'm done with my session. So if you have any questions, please come to it. I will happy to answer them.
Sure, I think Naveen is asking how endpoints captured automatically after pod restart.
So how?
How
And
endpoints captured? How is
mhm.
endpoints captured automatically after the pods restarts?
Okay, so Naveen, the thing is that when we are talking about Kubernetes services here, so let me go back here. So when we are talking about Kubernetes services here, so in the Kubernetes services, we are using selector. Okay, so this selector is for the pods. So this pod running with this, let's say, this pod running with this label is being selected in the service. So now let's say now I have two or three pods running there, which with the same label. So my service will target to those pods running with those label. So what will happen? One of my pod got crashed and it got restarted. So now the pod will be having new IP, but service will target the pods running with particular labels, and that queue proxy. So we are already talked that queue proxy will update the endpoints. So if you describe any of your service, you will find those updated endpoint there in the section. So that is done by the queue proxy and this service selector. Got it, Naveen? Naveen? Okay. Vishwas? Can
Oh, okay, I was in the mute. Sorry for that. So, I think
mm,
it's Vishal Kushwaha. So, if I've spelled your name right, yeah, I have spelled your name right. So, what is the advantage of using a stateful set over a normal replica set?
what is the advantage of?
Using stateful set over normal replica set.
Okay. So when we have the stateful we have the stateful application like databases and that kind of applications which we wanted to route through the headless services, or we wanted to use those application with the fixed name so I can access them, then we can go with the stateful set. So mostly those kind of database applications and the I think some like Elasticsearch or the Prometheus. Those are like stateful applications. Those can be deployed with the stateful set. But when we're having stateful application like let's say simple engineering server or the simple front end applications, then better to go with the deployment or the replica set, because that does not want the fixed pod name, that does not want the what we call headless service load balancing. Then we can go with the deployment or the replica set. But whenever we want something called load balancing with the name of the pods or name FQDN of the headless, then we have to go with the stateful set. So if I just show you example, so when we are talking about the stateful set, so those stateful set will be access like okay. So now what will happen? So if I'm just using any of my application, then what will happen? The stateful set name is web. So I can access web.web0. Using that I can target to the web0 pod. So when I want this kind of load balancing with the headless name, then I can go with the stateful set. And when we have the stateless applications like front end application, nginx, or simple applications, then better to go with the deployment. And the thing is that like when we are talking about the stateful set usually takes more time to come up because those are coming in the chronological way. Like first the pod running with the zero number will come up, then pod number running with the number one come up, and pod running with number two will come at the last. So that will be like sequential booting up. So when we are talking about the deployments, usually like we can have that option or we can have that privilege, like we can scale up the easily. That is the thing.
Got it. Sure, sure. I think Vishal's question got sorted. I think Digvijay is asking question like, "Hi, good morning, Vishal from RIT. I would like to know how K8s can be integrated with other DevOps tools like Ansible, Jenkins, etc." So
What
I
what
think
what?
I think he's asking something like, how can I integrate Kubernetes with other DevOps tools like Ansible and Jenkins?
So okay, so first thing is like if you talk about the Ansible is the configuration management tool, correct? So why, if you just understand the scope of the Ansible is for the configuration when we have large set of VMs and we want to configure something there, we can go with the Ansible. Okay, and if you still want to deploy your application using Ansible, then definitely you can use the API of the Kubernetes, and you can pass the secrets there. And using Ansible, you can call that, you can deploy applications using Ansible to the uh, Kubernetes. And when we are talking about the Jenkins, so job of the Jenkins mostly is the CI, correct? So for the CI means like building up the images. And if you want to use the Jenkins as a CD, then you can use the kube config map of the Kubernetes cluster, or you can use the Helm, what we call Helm build executors there. Using that, you can deploy your applications using Jenkins to the Kubernetes. So there are like multiple plugins in the Jenkins which will provide the support for that. But usually, like people are using Helm executors there.
Yeah, I think if you want to really learn more, I think don't worry about it. There's our entire project which is open on LinkedIn and it's free and open source. We are
Yes.
looking for a quality adoption. I think probably if you can come up with a use case which can really make a lot of impact, I think that's it, my friend. You're actually using the entire ecosystem of Devtron into your Kubernetes cluster. I think that's there.
Yeah.
I think docs.devtron.ai. I think there you can just go and see how it is easy to integrate anything and everything related to Kubernetes. I think you need not have to worry about anything. If your developers have no insights about Kubernetes, Devtron it is. So I think Naveen again has some questions. Any insights about admission controllers?
Okay. So first thing is like admission controller. So there are like two kinds of admission controller come in the actions, like who are gatekeepers. So if anything is coming inside the Kubernetes, that will be validated at the admission controller level. So there are like two kinds of admission control. One is the validating, and another is the mutating. So admission controller are also called as the webhooks. So the two types, one is validating, another is the mutating. So validating, for example, take for example, so I have write down the webhook which can avoid if my any applications running with the root. So that validating webhook will just discard that request. And the example of the mutating, if you are not defining any namespace name, by default it will add the default namespace and it will deploy in the default namespace. That is the example of the mutating one. So mutating will be changing your syntax on or configuration on the fly. So like we have implemented one mutating webhook that like if no one is specifying any request and resource configuration there, we are going with the default one. We can arrange that with the limit ranger as well, but we have implemented that using the mutating one, so that default one can be used there. So mutating will it will just mutate your what we call syntax on the fly before going inside the uh, deployment.
Sure, I think thank you so much, folks. Thank you so much for being till the end. I think there is a lot that we can do. If you want to get the on demand video, don't worry, I'm going to upload this right after the session on our Devtron channel on YouTube. Just go there, just look back at the sessions. Of course, there'll be a lot of timestamps added to it as well. So you can take your time, understand the video because Kubernetes 101 is not just a series that we just planned with respect to Kubernetes professionals only, but we are also getting a lot of use cases where Kubernetes is used in production. I think that is where we are planning out Kubernetes 101 to be, as well as helping you out with Kubernetes adoption the right way. And thank you so much, Vishal. Since we are out of time, I might not have to take any questions, but feel free to connect with us on LinkedIn. If you have any doubts and queries and questions, don't worry, just connect with us on LinkedIn. We are here to help you out. We're here for you at any given point of time. Thank you so much, Vishal. This is
Thank you.
Vishwas Nayan signing off from this live show, and thank you so much. Meet you soon in the next webinar, or the in person workshop of Kubernetes 101. Thank you so much, folks. Bye.